Hello and welcome. I am Dr. Geraldina Fernandez, Assistant Professor, Department of Science, the Bhopal School of Social Sciences. Dear students, in the previous session, we have already discussed about indefinite integrals. So now, in this session, we will be talking about definite integrals. When you were first introduced to integration as a reverse process of differentiation, the integrals you dealt with were indefinite integrals. The results of finding an indefinite integral is usually a function plus a constant of integration. In this module, we introduce definite integrals, so called because the result will be a definite answer, usually a number, with no constant of integration. Definite integrals have many applications. For example, in finding areas bounded by curves and finding volumes of solids. So let us define definite integrals. In the previous module, we discussed integration of f of x dx is equal to capital F of x plus c, where f of x is that function which, when differentiated, gives small f of x. That is, differentiation of capital F is equal to small f of x. For example, if we integrate sin 3x with respect to x, the result is minus of cos 3x plus c. Here sin 3x is f of x and capital F of x is minus 1 by 3 cos 3x. We now consider a definite integral which is simply an indefinite integral but with numbers written to the upper and lower right to the integral sign. The quantity integral a to b f of x dx is equal to capital F of b minus capital F of a. Here, the integral a to b f of x dx is called definite integral of f of x from a to b, where a and b are numbers. A and b are numbers. A is the lower limit of the integral and b is called the upper limit of the integral. We define integral a to b f of x dx is equal to capital of B minus capital of A, so that the definite integral is usually a number. So now, moving on to the properties of definite integral. The first property for definite integral is integral d to a f of x dx is equal to minus of integral a to b f of x dx. That means whenever you change the order of the limits, we get a negative sign multiplied to the integral. Second property of definite integral, whenever you have the upper and the lower limit same, then the value of that integral is equal to 0. The third property of definite integral is integral a to b f of x dx is equal to integral of f of x dx with the limits a to c plus integral f of x dx with the limit c to b. Now, the fourth property of definite integral is the integral of sum of two or more than two functions with the limit a to b is equal to the sum of the integrals with the limit a to b f of x dx plus integral a to b g of x dx. Now, the fifth property of definite integral is integral a to b c into f of x dx is equal to c into integral of f of x dx. Here, the product of a constant and function is equal to the product of the constant and integral of the function. Here, c is any constant. So now, we will proceed to the last part of our video, that is, we will solve some questions related to definite integrals. So now, moving on to solving some questions. So, first question, evaluate integral where the limits are from 2 to 3 x square dx. So, we have to evaluate this definite integral where the function is x square and the limits are 2 and 3. 2 is the lower limit and 3 is the lower limit and 3 is the upper limit. So we have to integrate the function for these limits. So we'll start with the solution. We'll assume this integral as I integral 2 to 3 x squared dx. Then first of all we will integrate x square by using the power rule, which is integration x raised to the power n dx is equal to x raised to the power n plus 1 divided by n plus 1. Here n is 2. You can see that the value of n is 2. So here n is 2. Therefore, we will use the same formula. We will get x raised to the power 3 by 3. Now, the limits are written to the right of the square bracket. So what we will do after this? First, we will put the upper limit in place of x minus the lower limit in place of x. So here the upper limit was 3 and the lower limit was 2. So we have to put the upper limit, then difference of the lower limit divided by 3. So here the answer will be 3 cube is 27 minus 8 divided by 3. That is equal to, so 27 minus 8 is 19 divided by 3. So this is the value of the definite integral. So with the help of definite integral, we get a definite number. So now moving on to the second question in this series, question number 2, we will evaluate integral minus 2 to 3 for the function x cube dx. Here the function is x cube, the lower limit is minus 2 and the upper limit is 3. So we will start with the solution. Let this whole integral be replaced with I. Now we will use the power rule of differentiation, which is integral x raised to the power n dx. This is equal to x raised to the power n plus 1 divided by n plus 1. So here in this particular function, the value of n is 3. So while integrating, we will get minus 2 to 3, the limits are minus 2 to 3, x raised to the power, here n is 3, so we put n as 3, so we will get 3 plus 1 divided by 3 plus 1. For the limit minus 2 to 3, which is equal to x raised to the power 4 by 4, for the limit minus 2 to 3. So in this particular step, after this we will put the upper limit is 3 in place of x minus the lower limit in place of x. So here we will get x is, upper limit is 3. So we will put 3 raised to the power 4 minus of, the lower limit is also having a negative sign. So we will put minus 2 raised to the power 4 divided by 4. 3 raised to the power 4 is 81. So 81 minus of negative raised to the power 4 will become positive and 2 raised to the power 4 is 16 divided by 4. So on simplifying it, we will get 65 divided by 4. So we can give the answers in decimals also, but this will be okay for us. 65 by 4 is the value of the integral. With this, we come to the end of the topic definite integrals. I hope this session will be a fruitful session for you all. Thank you.